Okay, what we have here is we have a triangle, and we have a square here, a square here, and a square here. And our objective is to find the area of this unknown square here. We do not know the area of this square, but we do know the area of the two squares here, and they're all involved in this triangle here. So here's how we're going to do it. I'm going to use this triangle here as a central point to this question. Now, I'm going to deal with this square here. Now, I need to find this length here. Now, the area of a square, is if you multiply the two sides, the two lengths by each other, L multiplied by L. Now, the area of this particular square is 25. So I'm going to say 25 is equal to L by L is L squared. And if I want to figure out L, I must square root both sides of the equation. And the square root of 25 is 5. So 5 equals L. So I now know the length of this side here. So that length there of that side is 5. I now want to find the length of this side here. Now, I know the area of this square is 16, so I'm going to go area of square equals L squared again. And the area of this particular square is 16. So 16 equals L squared. And if I want to find L, square root both sides, and the square root of 16 is 4, and the square root of L squared is L. So 4 is equal to this length here. And if you want to test it, the length of that side is 5, the length of that side is 5, the length of that side is 5, because that is a square, and 5 multiplied by 5 is 25. Same as this one here. That length is 4, that length is 4, that length is 4, and that length is 4. And if you go 4 multiplied by 4, you get 16 as well. So we now want to find out the area of this. And to find the area of this square, I need to figure out one of the lengths. And if I figure out one of the lengths, I can then work out all of them. Now I'm going to use this triangle here to find this length here. And that triangle is a right angle triangle. And I'm going to write it just here. There it is. So that side is 5. That side is unknown, so I'm going to call it x. And this side here is 4. Now, to figure out the length of this side, I've got to use a 4-step process. And that is L, F, S, S. And the first L here stands for label. So I'm going to label the triangle, and it's a right angle triangle. So this side here is the longest side, and it's opposite the right angle. So that's H, the hypotenuse. This one here and this one here, I can call them the opposite and the adjacent, or I could call them the adjacent and the opposite, whichever you like. You can swap those around. So we now have them labelled. That's the hypotenuse, the longest side opposite the 90. That is our opposite side, and that is our adjacent. The next step is the formula. And in a right angle triangle, if I have two sides and I wish to find the third, I use the Theorem of Pythagoras, which is h squared equals o squared plus a squared. My first S is sub, so I'm going to sub in my information here in for the letters, and h is 5, so that becomes 5 squared. The opposite side is x, so that becomes x squared, and the adjacent side is 4, so that becomes 4 squared. Now the last S is solved, so let's work this out. 5 squared is 25, x squared is x squared, 4 squared is 16. And I want to get x squared on its own, so I subtract 16 from both sides, and I get 9 equals x squared. And to get x on its own, I must square root it, and I must square root this side also, and the square root of 9 is 3, and the square root of x squared is x. So I now know that x is equal to 3, and x is that side of the triangle, so I'm going to put 3 in here. That's a square, therefore that side is 3, that side is 3, and that side is 3. So all 4 sides of this square are 3, and to find the area of this square, area equals L squared, and the length of one of these sides in this case is 3, and 3 squared is 9. We have therefore worked it out. So the area of this unknown square here was 9, and we used a few different things there. We used area of a triangle, we used the Theorem of Pythagoras, and then we went back to the area of a triangle, area of a square I should say, and that is the question completed.